All right, this last example we're going to look at is kind of a real world example of a geometric series, and it has, or a geometric sequence, and it has to do with an annuity. So in case you don't know what an annuity is, it is a sequence of equal payments that are made at equal time periods. And if you're thinking about retirement, an IRA, which you may have heard about or you may hear about in the future, an IRA is an individual retirement account that you can add to yearly, monthly, however you want, up until the time that you decide to draw it out when you retire, and it is tax deferred. So an IRA is basically an example of an annuity, and we're going to look at the value of an annuity if you start depositing in it now at age 25. So that's the example we're going to look at. We're going to follow the formula that you see there. At age 25, if we want to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. And you want to know at the end of that, when I retire at 65, how much is going to be in that annuity. So what do we need to know first? Well, I need to know what these terms are up here. I need to know what P, R, N, and T are out of what I've been given. P is going to be your principal, or the value that you initially invest. In this case, my P is going to be $200. R is going to be 0.075. That's the interest rate that we're going to take monthly. We do this monthly, so N out of that formula has to do with the number of times that you are compounding yearly, based on a year. And so there are 12 months in a year, so we're doing it monthly. So N is equal to 12. T is going to be how long are we investing in this annuity. If I retire at 65 and I start doing it when I'm 25, that's a total of 40 years. So T would be 40. Now, the formula says I'm going to take the annuity is going to be equal to P times 1 plus R over N raised to the NT minus 1, and I'm going to divide that by R over N. So let's fill in the formula as it is. So P would be 200, and I'm going to multiply that times 1 plus 0.075 divided by 12 raised to the 12 times 40 minus 1 divided by 0.075 divided by 12. There's a couple of ways that you can do this. Either way, we're just going to be putting it into our calculator. So let's pull the calculator up, and I'm going to clear this out. I'm going to scoot it over just a little. You may not be able to see all of it, but well, maybe I could scoot it this way. That'll probably work better. So if I have the calculator here, so I'm going to start from the inside out, and I'm going to do everything that is in this bracket here first. So because I have the calculator that'll do that, I can say 1 plus, and I'm going to take the fraction of 0.075 divided by 12, not 0.72, 0.75, divided by 12, close the parentheses for the fraction, close the parentheses for the 1 plus the fraction, and I'm going to raise that to 12 times 40 times 40. Come out of the exponent position, and I'm going to subtract 1. You don't have to do all of that in your calculator if you don't want, but that's what I'm going to do. So I have 18.89. Now I'm going to multiply. So what did I get? I got 200 times 18.89, and I'm going to divide that by 0.075 divided by 12. So I'm going to take 200, and I'm going to multiply it times that previous answer to avoid any rounding errors, and I'm going to hit enter, and I get approximately 3,779. So that's approximately 3,779 that I'm going to divide by 0.075 divided by 12. So I'm going to divide that now by 0.075 divided by 12. Close my parentheses, hit enter, and there is the value that I am actually looking for. $604,764.43. So $604,700, and we'll just round it up to the nearest whole number, $604,765. Wow. So if you could find it when you're 25 and you have your first job, if you just automatically start putting in $200 a month into this type of an annuity that's compounded monthly, when you decide to retire at age 65, you're going to have $600,000 solely in that tax-deferred annuity. That's pretty impressive. Most of the time, if you just start putting away the money, if you just have it automatically taken out of your account from the beginning, then you never really miss the $200. Now, the second part of this question says, how much interest did you earn in the lifetime of this annuity? So if I want to talk about that, I'm looking at the interest earned, which would be equal to the total value of the annuity, 600, well, let's just write it like this. It's the value of the annuity minus my total deposits that I put in. So in other words, the 604,765. Now, how many deposits did I put in? I put in $200 a month, so that would be 12 times the years of 40 years, because I did that for 40 years. And when I subtract this out, when I do the subtraction here, you'll find that the interest that you earned on the money that you were depositing is $508,765, which is pretty impressive, because if that's the interest that I earned over 40 years, it's more than 5 times the amount of your initial contributions on your IRA. So that's pretty impressive. It's pretty hard to think about retirement right now, probably, but it's something that you can kind of consider when you're looking at these sequences.